Okay, ladies and gentlemen, this is the Chapter 1, Lesson 5 video on parametric relations and inverses. We have two objectives. The first one is to define relations parametrically. The second one is to find inverses of relations and functions. We're going to first talk about parametric relations. We can define functions or relations by defining both elements of an ordered pair in terms of another variable. This other variable is what we call a parameter. Alright, so in other words, we can define x as a function of time and y as a function of time. And why are we using time? Because when we deal with parametric equations, time tends to be what the parameter is. Okay. Yeah, so I say tens because here we look, our parameter is t, however, it doesn't look like it's going to represent time because of the negative t values that we have. So, nonetheless, let's look at this parametric relation. All right, and hopefully hopefully by looking at this, we have a better understanding of what it is. And what it is a parametric relation, two equations using three variables to describe something that we would write with two variables in one equation. So that's what a parametric relation essentially is. We want to right now plug in our t values. Alright, so let's plug in -3 for t and get what x is here, and then plug -3 in for t here and get what y is. So this is what we're going to do first. So -3 plus 1 is going to give me a -2, and then a -3 squared is 9 plus -6. So it's going to give me 3. So -2, 3 is my ordered pair. Plug in 2 here. Alright, -2, plug in -2 plus 1 is -1. And then -2 squared is 4 plus -4. So we're going to have 0 here. So -1, 0 is my ordered pair. What I want you to do right now is hit pause, work out the rest of them on your own. When you're finished, hit play, and I'll have the answers up. Okay, and here are the answers. Hopefully when you work yours through, they match what I have here. Alright, to the second part of this first example. We want to find an algebraic relationship between x and y, and then answer the question, is y a function of x? So let me rewrite our parametric relation. So that was x equals t plus 1, and then y equals t squared plus 2t. So what I'm going to be doing here is finding, so we have the two equations with three variables, alright, and I said that this is used to describe what we usually would write with one equation and two variables. So we're going to find that one equation right here. This is that algebraic relationship. So in order to do that, we got to get rid of one of our variables. So we're going to get rid of t, right, because we want a relationship between x and y. And how are we going to do that? We're going to do that through substitution. So I'm going to write x equals t plus 1. And I'm going to solve for t. So t is going to equal x minus 1. And I'm going to plug this into here. So I have y equaling x minus 1 squared plus 2 times x minus 1. Alright, and so this is going to give me x squared minus x plus 1, distribute, and I did this by foiling, so you can expand this, and then FOIL, and that's what you get here. Alright, and then add 2x minus 2. Combine like terms, so I have x squared, negative x and a negative x is a negative 2x, but that cancels out with this positive 2x, so I just have a positive 1 and a negative 2, so I have x squared minus 1. So y equals x squared minus 1. This is a function, y is a function of x here, and this shows the algebraic relationship between x and y, and it corresponds to my parametric relationship, or my parametric relation. I can show that by plugging in points. So y equaling, what did I have? X squared minus 1. So if I plug in points, so if I plug in negative 2 for x, notice how I get out 3 for y. Plug in negative 1 for x here, so negative 1 squared is 1. 1 minus 1 is 0. I'm good here. So for all of these, I'm good. So I've shown that this and this, I've shown the relationship between the two. Alright, in part 3, all you have to do is graph the ordered pairs. So here's what that should look like. In class, what I'm going to show you how to do is graph the parametric relation using your graphing calculator. That's explained in this slide. I believe it's too hard to do over the too hard to do on this video, so we'll save it for in class. Okay, so what I want to do right now is start talking about the second half of this lesson, and that's about inverses. Specifically, right now, inverse relations. What's an inverse relation? So an inverse relation occurs when you just basically switch your x and your y. So here's a relation, alright? The relation happens to be a function, so this whole thing. The inverse relation is just the ordered pairs, but flipped. So 3, negative 2. And I'm just writing these, I'm switching the x and the y. 0, negative 1. Negative 1, 0. 0, 1. 3, 2. 8, 3. Alright, so that's the inverse relation. Now, let's graph these. So 3, negative 2. 0, negative 1. Negative 1, 0. 0, 1, 3, 2. And 8, 3. So I want to graph these and connect. And what we're going to be talking a lot about is determining if the inverse is a function or not. So if I look at this relation, is it a function? Well, if I draw a vertical line through the graph, it intersects it at more than one point, so this would fail the vertical line test, and as a result it's not going to be a function. Now there's a trick. We don't have to actually draw the inverse. We can just look right at the original relation. If I draw if a horizontal line intersects the original relation at more than one point, then we know that the inverse is not going to be a function. Right? So this fails the horizontal line test, therefore the inverse is not going to be a function. Right? The other thing that I want to point out is that I have my original relation, or my original function here. The inverse is going to be the graph of this reflected across the line y equals x. So here's the line y equals x, and hopefully you can see it's not too messy. Hopefully you can see that this graph, when it gets reflected across this line, y equals x, gives you this graph, and that's the inverse. Okay, so just a moment ago we were talking about the horizontal line test. Let's just kind of define it and do some practice example problems. So the inverse of a relation is a function if and only if each horizontal line intersects the graph of the original relation in at most one point. In the diagrams below, star the relations that are functions and check the relations that have inverses that are functions. Alright, so we're going to look at the graph at each of these. I'll start with the first one, and let's determine if this relation is a function. So it clearly passes the vertical line test. Alright, so this is going to be a function. So I'm going to start. However, it fails the horizontal line test. So the inverse of this function is not a function. Okay, on your own, I want you to do B through H. When you're finished, hit resume and I'll have the answers up. Okay, here's what your answer should look like. Call your attention to D here. That may have been one that was confusing to you, but we're not constant in this interval here. We're going to be increasing ever so slightly. So that will pass the vertical line test. It's a function. And since it passes the horizontal line test, the inverse is also going to be a function. Now, a function whose inverse is a function has a graph that passes both the horizontal and vertical line test. We say that such a function is 1 to 1. Alright, so looking back here, this function, this one, this one, this one, this one, these are all functions that are 1 to 1 because they pass both the vertical and the horizontal line test. Now, such a function is 1 to 1 since every x is paired with a unique y and every y is paired with a unique x. Alright, so now next section is inverse functions. We got a very nice and simple definition here, so that you can really sink your teeth into. So if f is a 1 to 1 function with domain D and range R, then the inverse function of f, denoted f inverse, is the function with domain R and range D, defined by f inverse of b equaling a if and only if f of a equals b. So that was a mouthful, alright, but I want to do a little example to basically summarize what we just read. Okay, so I have right here a function that is 1 to 1. I know it's 1 to 1 because this is a line and it passes both the horizontal and the vertical line test. I'm going to name this function f of x. Alright, we're going to learn how to find the inverse in a minute, but for right now we won't find it. I'm just going to give you what the inverse of this function is. It's y equals x minus 1 squared, and this is f inverse of x. And so I just wanted you to be aware of what the inverse function actually does. So if we have a number 2, right, and we plug it into f of x, and so we take 2, we plug it into f of x, what are we going to get out as our output? we are going to get 5 out. 2 times 2 is 4. 2 times 2 is 4. Actually, no, we're going to get, back this up. 2 times 2 is 4. 4 minus 1 is going to be 3. So we're going to get 3 out. Okay, I caught my error. What I really wanted to do was use the function for f of x, y equals 2x plus 1. Alright, and so then this would be f inverse, and then when we go ahead and plug 2 in for x, so 2 times 2 is 4, 4 plus 1 is 5. Alright, so when we plug in 2 into f of x, we get 5. Now, what the inverse function does, right, is it takes the output and maps it back to the original input. So when I plug 5 into the inverse function, alright, so I'm going to take 5, plug it into here. So 5 minus 1 is 4, and then 4 divided by 2 is 2. Alright, so that's essentially what an inverse function does. Alright, so hopefully that made some sense of all that. Alright, now we're going to find the inverse function algebraically. Alright, so here I gave it to you. Now we're gonna learn how to find it. And then here are the steps that we're gonna follow. Alright, so we want to find an equation for f inverse of x if f of x equals x divided by x minus 5. Alright, so the first step is to just write out f of x equaling x divided by x plus 5. Alright, and then you want to write what the domain is. So the domain is going to be, x can't be negative 5. Right, that's our only restriction on the domain. So we're going to go from negative infinity to negative 5. It can be in that interval, or it can be in the interval from negative 5 to, oops, don't want to do that. There should be a comma. Positive, getting close. No. Okay, there should be, there we go, a parenthesis around that. So there's our domain. Now the range, right? So the range you want to graph, and if you graph the range, you'll find that that is going to be from negative infinity, right? We have a horizontal asymptote at 1, so let's look at my degrees. They're the same. This is 1, that's 1. 1 divided by 1 is 1. So my range is going to be from negative infinity to 1, and then from 1 to positive infinity. Alright? So once I've stated the domain and the range, I've wrote down what my problem was. I'm now going to write it y equals x divided by x plus 5. And then once I have it written like this, I'm going to switch my x and my y's. So I'm going to write x equals y divided by y plus 5. And when I do that, I have to change the domain and the range. I've switched the x and the y, so my domain and the range are going to switch. And so my domain now is going to be from negative infinity to 1, and in the interval from 1 to infinity. Alright, so it's very important. Now, I'm going to go ahead and solve for y. So I'm going to multiply both sides by y plus 5. So I have y plus 5 times x equals y over y plus 5 times y plus 5. So this cancels. Distribute the x, so I have y times x plus 5x equaling y. And then I'm going to subtract y times x from both sides. And I'm going to get 5x equals y minus y times x. And now I'm going to factor out a y. So 5x equals y times 1 minus x. And now I'm going to divide 1 minus x by 1 minus x. And so y is going to equal 5x divided by 1 minus x. And then the last step, since I basically found the f inverse of x, is to replace x, replace y, get rid of the y, and write f inverse of x in its place. Alright, so there is f inverse of x, and then my domain, is this right here. Alright. Okay, the inverse reflection principle, we talked about that earlier. It says the points A and B, A comma B and B comma A in the coordinate plane are symmetric with respect to the line y equals x. The points A comma B and B comma A are reflections of each other across the line y equals x. Alright, so if we have a relation, the inverse of it, the graph of it, is going to be a reflection of that original relation across the line y equals x. And it says on your paper, on your guided notes, to sketch a graph of the cubic function and then find its inverse. I think it's easier if you just change that problem to x cubed plus 2. Make a quick sketch of that graph, looks something like this, and then you can go ahead and reflect that thing across the across y equals x and kind of see what you get, and we can kind of compare our graphs in class on that one. Alright, finally we want to verify inverse functions. So we're going to do this by the inverse composition rule. So to show one function is the inverse of another, use the inverse composition rule. It says a function f is 1-to-1 with inverse function g if and only if f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. Okay, so what does that mean? Let's apply it to this problem. Alright, so we got to confirm the following functions are inverses. So we have f of x and g of x, so we want to show that f of g of x equals x. So we got to plug this into f of x. So I'm going to have the cubed root of x minus 1 cubed plus 1. Alright, so the cubed root cubed, that'll cancel each other out, so I just have x minus 1 plus 1, so this is just going to equal x. Right. So that's good, we're good there. So now we got to do g of f of x. Alright, so now let's erase that. So now we got to plug f of x in for x here. So we're going to have the cubed root of x cubed plus 1 minus 1. So this is going to be the cubed root of x cubed, because plus 1 and a minus 1 equals 0. And then the cubed root of something cubed, those cancel out, so I'm left with just x. Alright, so these are going to be inverses of each other. Alright, so this video was a little long. I tried to make it as short as I could. I hope it was helpful. Have a great weekend, and we'll see you guys back here on Monday.